Hello, this is question 9 on your 2018 paper from Edexcel, your A-level maths paper, and it's a moments question. So you have a plank AB, so this one, they give you the mass, they give you the length, and it is dressed against a rough vertical wall here. So we have a rough wall, and the plank is held in horizontal position by a rope. So we have a rope here, but this is the plank, yeah. One of the rope is attached to the plank at B, and we know this angle here. So we know that tan of that angle is 3/4. Then you have a block of mass 3m here, and the distance to the wall is x. The plank is modeled as uniform rod, so which means the weight is in the midpoint. And the first thing we have to do is to show that the tension in the rope is this value here. So the first thing you have to do with these questions with forces is always a force diagram. So we are going to draw all the forces that we have. So we have the weight of this block here, that is 3m and m times by g. Then the weight of the plank itself, the mass is m, so this is going to be mg, and this is going to be in the midpoint. I know it's not in the midpoint exactly, but it's midpoint. It's just my drawing. Then we have the tension at B. This is a string or a cable, so we have a tension, and that's the tension that they ask us. And then at A, I have friction. Remember, always against the direction of the motion. So if this was slippery, the plank will slip down. So this is against that. And then I have a normal reaction perpendicular to the wall, and I'm going to call it R, for example. Yeah. So these are the forces that I have, and I have to find the tension. Remember, it's in equilibrium. In equilibrium means two things: that sum of forces, resultant force, is 0, and moments about any point is 0. So if I think of it, what to take moments about, it will be very helpful, because I have, if I take moments about A, for example, these two forces won't give me any moment. So I don't have them in the equation, but I have T. So I'm going to take moments about A. It's the most convenient, yeah? If I take moments about A, and I'm going to do it in the next page. So for A, moments about A is going to be 0, which means the clockwise are going to be the anti-clockwise. So this is producing a clockwise moment. This is producing a clockwise moment, both of them about A, yeah? They are producing clockwise moment, and this one is producing an anti-clockwise moment. So clockwise will be equal to the anti-clockwise. Let's start with this one, the clockwise. So mg times this distance, and this distance, the whole bar is to A, and this is the midpoint, so it's going to be A. So mg times A. So force times distance, plus the other force is this one, 3mg, and this is distance x. So 3mg times x. So force times distance is going to be equal to the anti-clockwise, and the anti-clockwise is the tension times perpendicular distance from the point to the line of the force. This is the line of the force, so we are talking about this distance here, perpendicular. Yeah, so if this is perpendicular here, I need this distance here. This distance here, if I look at this triangle, which is a rectangle triangle, doesn't look very much like a rectangle triangle, but something like this, yeah? So if I look at this triangle, this is the opposite to the angle, and I know the hypotenuse is 2a. So this is going to be 2a sine alpha, because it's the opposite, yeah? So this is going to be 2a sine alpha. And I know tan alpha. I know that tan alpha is 3/4. Yeah. So remember, when I have this, I can do tan minus 1 and find the angle, and then the sine or the cos, but it's even better if I use this triangle, because the numbers are quite easy. So if this is alpha, and tan is going to be opposite divided by adjacent, with Pythagoras we know this is 5, which means sine alpha is going to be 3/5. Yeah, so this thing here is going to be 2a times 3/5, which is going to be 6a divided by 5. Yeah, which is easier. That's the distance. So this is the distance that I'm going to write here. It's going to be t times 6a divided by 5. Yeah, 6a divided by 5. And from here we find t. So if I multiply, I can multiply everything by 5, but they have the 5 outside, so actually I'm not going to multiply. Yeah, so I multiply. I have a bracket. I'm just trying to think how we can write this faster. So I'm going to factorize this thing here with mg outside. So mg is going to be a plus 3x is going to be t times 6a divided by 5, which means that t is going to be 5 mg brackets a plus 3x all divided by 6a. And I think it's what I have there, no? Is that? Yeah, so that's the first part. Just taking moments about A. Then the magnitude of the horizontal component of the force exerted on the plank at A is 2 mg. So this force here is 2 mg, is given. Yeah, I wrote R because I didn't know the value, but I know the value is 2 mg. And it says find x in terms of A. We need to find the distance. So we can, if we take moments, still we don't know the t, like we didn't know before, but they are giving us this horizontal force. So if we use horizontal force equals 0, the only forces horizontal that we have is this one pointing this way, and the horizontal component of this one here. So I have this horizontal component here, which is t cos alpha. Yeah, and cos alpha from here is 4/5. So I have t times 4/5 or 4/5 of t. That looks slightly better. Yeah, so this force is going to be equal to this force because I don't have any other horizontal and it's in equilibrium. Yeah, so 2 mg is 4t divided by 5. So for B, 2 mg is going to be 2/5 of t. No, do we say 4/5? Sorry, 4/5. And I have an expression for t, which is this one. So I'm going to write this because this includes the x and I need x. So instead of t, I'm going to write 5 mg a plus 3x divided by 6a, and then I'm going to simplify until I have my x, my expression for x, right? I can cancel this 5 with this 5. From here I can cancel 2 with this 2, and again this 2 and have a 3 here. I can cancel mg with mg, and then here I have 1 multiplied by 3a, is 3a, so I have 3a equals, and in the other side I have only a plus 3x, which means that 3x is 2a, which means that x is 2/3 of a. Yeah, so that's it. And that's the value of x in terms of a. Then the next one is the force exerted on the plank at A by the wall acts in a direction which makes an angle beta with the horizontal. We need to find that beta. They are talking about the combination of these two forces, right? The combination of these two forces make an angle with the horizontal, which is beta, and we need that one. Yeah, so these are like the two components of my force, combined force in A. To find tan beta, I have this value here, I will need this one here, and this one here is the friction, yeah, it's the vertical component. So again, we can apply forces, I would say, or we can apply moments, it doesn't matter. So we can apply vertical forces, or we cannot take moments about B, for example. It's really up to you. I'm going to apply some forces in the vertical direction. So for C, this one was forces in the horizontal direction, and now I'm going to apply forces equal 0 in the vertical direction, right? So forces pointing up, like my friction, and the component of the tension, the vertical component of the tension here is T sine alpha. And sine alpha, remember, is 3/5, so it's 3/5 of T. 3/5 of T. And it's going to be equal to the two forces that I have pointing down. So mg plus 3mg. So forces pointing up plus forces pointing down. Mg. I need friction. And I know the tension, yeah, because I have an expression for the tension. In fact, I know now x. So x is 2/3 of A plus A. Yeah. So let's find first T, so we can substitute and it looks nicer. So 5mg. I'm just using the formula for T, but I'm substituting x by the value. So it's 5mg times A plus 3x is going to be 3 times this, which is the 3 are cancelled, so 2a. 2a plus 2a divided by 6a. And I have 5mg. 3a divided by 6a is 2, so times 2. And this is 10mg. And just, it looks better and simpler. No, 5/2, sorry, 5/2. 5/2. That's my tension. So I'm going to substitute that tension here, and I'm going to find the friction. So I have friction plus 3/5 times the tension, which is 5/2 mg, is going to be 4 mg. These are cancelled, and I have friction is going to be 4 mg minus 3/2 of mg, which means is 5 mg divided by 2, 5/2 of mg. This is the friction, so I have my friction here, and the horizontal force was this one, was 2 mg. Yeah, so if I find tan beta is going to be opposite divided by adjacent, so the friction divided by 2 mg. So tan beta is going to be the opposite, which is the friction, so 5/2 mg divided by the horizontal reaction, that was 2 mg. These two are gone, and then I have 5/4. So this is tan beta. I don't know if they ask me beta or tan beta. Tan beta, yeah? So I don't need to find the angle. So that's the answer. Tan beta is 5/4. What does it say? The rope will break if the tension in it exceeds 5 mg. Explain how this will restrict the possible positions of P. So the tension cannot be greater than 5 mg. So the tension must be, this was D, no? D. Tension must be smaller or equal than 5 mg, because if it's greater than that, will break. I have an expression for the tension, which is this one. And I'm not going to use this one because this is for a particular value of x, while now I can move this one right or left, and they're asking me what is the farthest that it can go without breaking it, yeah? So I need to leave it in terms of x. So tension, which is 5 mg, a plus 3x divided by 6a, must be smaller or equal than 5 mg. So I can cancel 5 mg, and I have a plus 3x must be smaller or equal than 6a, which means that 3x must be smaller or equal than 5 a, which means that x must be smaller or equal than 5a divided by 3. So that's my limitation. X must be closer than 5a divided by 3 from a. Yeah, so the maximum distance, it will be 5a divided by 3. And that's all with this question. It's just that.